Now let us see some of the examples based on the fundamentals of quadratic equation. Here is the first question. If roots of x square minus 8x plus a square minus 6a equal to 0 are real and distinct, then find all the possible values of a. Now we know that the condition for roots to be real and distinct is nothing but the discriminant should be greater than 0. So writing down the value of discriminant is, see here b stands for the value minus 8, which is b, and a is 1 and c is nothing but a square minus 6a. So substituting those values we get minus 8 the whole square minus 4 times 1 into a square minus 6a. This should be greater than 0. So we get 64 minus 4 into bracket a square minus 6a greater than 0. Now cancelling the factor of 4, we are left with 16 minus into bracket a square minus 6a greater than 0. So on opening the bracket we have 16 minus a square plus 6a greater than 0. So if you just rewrite that keeping a square term in the beginning, that is minus a square plus 6a plus 16 greater than 0. Now to make the coefficient of quadratic term as plus 1, we have to multiply both sides of the inequality by minus 1s. So changing that, the inequality will also get reversed because we are multiplying by a negative number. Now the expression on left hand side can be factorized as a plus 2 into a minus 8, which is less than 0. Now here we arrive at a stage where the product of two particular quantities is negative. So that means either one quantity is positive and another is negative, or the vice versa. So if you consider the first case, that is a plus 2 is positive and a minus 8 is negative, then we get a is greater than minus 2 and a is less than 8. So in other words, it means that a lies between minus 2 to 8. This is one possibility. Now if you think of the other case, that is, it might be possible that a plus 2 is less than 0 and a minus 8 is greater than 0. So that gives us a is less than minus 2 and a is greater than 8. Now we have to note that both of these two conditions must be true simultaneously, and we know that this is not possible because a cannot be simultaneously less than minus 2 as well as greater than 8. So therefore this is an invalid case, so we discard it. So that means the final answer is nothing but a must lie between minus 2 to 8 for the roots of the given equation to be realized. Now there is another shortcut method also by which we can find out these two values quickly. For that, let us go back to the inequality where we have the product of two factors. Here we have to note the exponent of each factor also, that is both have the exponent as 1. Now what do we do is, like when we rewrite this particular expression, we have to write down the values which make a particular factor as 0. So if we think of the first factor, if we put a as minus 2, then it will make that first factor 0. Similarly, if we make a as 8 in the second factor, it will make that second factor 0. Now with these two values, minus 2 and 8, we plot them on a number line. So say here it is minus 2 and here it is 8. Now what we have to do is we have to start assigning the signs either plus or minus to various intervals. Now we can observe that the two values will break the entire real number line into three parts. 3 intervals. To the rightmost side we always mark plus. As we travel from right to left, that is we have to cross one particular value. Now here we cross the value 8 first. Now while crossing the value 8, we have to go to the factor of that is a minus 8. Now we observe if the index of that particular factor is odd, which is 1 here. In that case we change the sign from plus to minus. If it were even, then we keep the sign, that is we would have in that case marked still as plus. But now here we mark as minus because it is exponent 1. Now further, as we cross the value minus 2, we have to check the factor of a plus 2, and here also we have the exponent as 1, which is odd. So therefore now we will change the sign back to plus. So the significance of these signs is nothing but wherever we have put the sign as plus, in that particular interval the expression on the left hand side will be positive, whereas wherever we have put the negative sign, there it is negative. And since we want the expression to be negative, which is less than 0, the answer is that a must lie between these two values, that is minus 2 and 8. Let's move ahead to the next question. Now here, if roots of the equation a into b minus c times x square plus b into c minus a times x plus c into a minus b equal to 0 are equal, then show that 2 upon b equal to 1 upon a plus 1 upon c. And now here the condition for equal roots, as we know, is nothing but delta should be equal to 0. So therefore writing the expression for delta, it is b square. So here it is nothing but b square into c minus a the whole square minus 4 into a. Now the a is nothing but in this particular case the coefficient of x square term. So therefore we have a into b minus c, and we have to multiply by the c in the original convention, which is nothing but the constant term. So that is nothing but c into a minus b equal to 0. So let us expand the square. So we will have b square into c square minus 2ca plus a square minus, we can merge this a and c, making it as 4ac multiplied by, we can now multiply the two brackets. So that is ba minus b square minus ca plus bc equal to 0. Now on simplifying further, we will get that this expression is equal to ab plus bc minus 2ac the whole square equal to 0. So basically the left hand side is nothing but a perfect square as shown here. So therefore it leads to ab plus bc minus 2ac is nothing but equal to 0. So therefore taking 2ac on other side, we have ab plus bc is equal to 2ac. And now if we divide both sides by abc, as we can now compare with the expression that we want to prove. So dividing by abc, we get 1 upon c plus 1 upon a is equal to 2 upon b. So that proves the required answer.